Good afternoon, my dear learners. I am delighted to have this opportunity to make another video in chemistry now to target those who are studying chemistry 0620, that is Cambridge. I am going to do this video for those learners, and the topic on target this time is acid, bases and salts. Specifically, I will be answering questions extracted from past papers, originally from the characteristic properties of acids and bases as the subtopic. So without wasting time, my learners, we are going to start answering these multiple choice questions. So we are going to start with question number 1. Question number 1 reads, the diagram shows the pH values of 4 solutions. We are having the values ranging from 1 to 14. We understand that this indicates the pH scale, and in most cases, the pH scale ranges from 0 to 14. Now the question is saying, which of these solutions are alkaline? So, we are having the solutions represented by letters P, Q, R, and S. Now, we are not supposed to forget the concept, my dear learners, that the pH scale ranges from 0 to the pH of 14. We understand that we have those substances that have the pH of 7, those are called neutral substances. Now, from the central point where we have the neutral substances, those substances with the pH value less than 7 are called acidic substances, and those with the pH value greater than 7 are known as alkaline substances. Now, what is the question asking us to do? We need to look for those solutions that are alkaline in nature, and you witness with me that out of what we have, the only solutions that are alkaline are R and S. So here our correct answer is D. We continue. Question number 2. An element E is blended in air. A white solid oxide is formed. The oxide is then tested with damp red litmus paper. The paper turns blue. What is element X? What is element E? I like a letter X, so forgive me. So, what is element E? Now, looking at what we are having, my dear learners, we are having this element E. This element is able to react with oxygen to form an oxide. And this oxide, according to the property we have just witnessed, is that it is able to turn a red litmus paper blue, indicating that this solid oxide should be a basic oxide. Now, out of the options, which substance, which element do you think is able to produce a basic oxide after reacting with oxygen? A, calcium. B, carbon. C, iodine. D, sulfur. Here the answer is A. Calcium oxide is the only metal out of the options which is able to produce a basic oxide. Remember, basic oxides are oxides of metals. Now, when we look at carbon, carbon is a non-metal. Iodine, iodine is a non-metal. Sulfur, sulfur is a non-metal. So the only answer is A. Moving forward, we go to question number 3. Some reactions of a substance R are shown in the diagram. Substance R. Substance R react with magnesium to form hydrogen gas. Now, looking at magnesium and substance R, we can guess that this substance is likely to be acidic because metals react with acids to form hydrogen gas as one of the minor products. Acids also react with metal carbonates to form carbon dioxide as one of the minor products. Acids also react with metal oxides to form salts. Therefore, here the only answer which has qualified is A. This substance must be an acid. For those people who would like to understand more, you can observe on what I'm going to do. We are going to say, okay, let us make this substance to be sulfuric acid, for example. If the substance is sulfuric acid, then we say sulfuric acid plus magnesium. Here we are going to form magnesium sulfate plus hydrogen gas. This hydrogen indicates what we have there. Again, we come to sulfuric acid plus sodium carbonate. Sodium, being a metal, is going to react with a sulfate to form sodium sulfate plus we are going to have hydrogen reacting with oxygen to form another product which will be water. When we remove one oxygen atom from a radical carbonate, we are going to remain with two hydrogen atoms bonded to one carbon atom, and that will become carbon dioxide. And this carbon dioxide indicates the products there. When we get sulfuric acid reacting with copper 2 oxide, a black solid substance, we are going to have copper reacting with a sulfate to form copper 2 sulfate, which is indicated here. So this substance crude is supposed to be an acid. I am trying to teach you, my learners, as I answer the questions, so you should bear with me that I'll be taking some time, because what you need are concepts and not just the answers of today. We go to question number 4. Question number 4 reads, substance K react with sodium carbonate to form a gas. The gas is known, but we know that it's a gas. But this gas turns lime water cloudy. That's the physical property, because we are able to see. What is substance K and which process takes place in the reaction? Now, looking at what we have, what we are going to target is that at the end of the day, we should have a gas which should be able to turn lime water milky, and that gas is every time carbon dioxide. So we should look for a possible reaction which, when that substance reacts with sodium carbonate, should be able to give us carbon dioxide. Now, which substance is that? We are going to look at the processes. We have combustion. Now, is it possible that we can burn sodium carbonate to produce carbon dioxide in such a way that we burn sodium carbonate together with ethanol? It's not possible, my dear learners. So here, this answer is not possible. Ethanol, we react ethanol plus sodium carbonate. This reaction does not exist. Hydrochloric acid, which is HCl plus sodium carbonate, This process is possible, but the process is not combustion. This process where this carbonate reacts with an acid is known as neutralization reaction, because the sodium carbonate will neutralize an acid to form a neutral salt or a normal salt known as sodium chloride plus carbon dioxide plus water. This reaction is known as neutralization reaction, so the answer cannot be C. D, hydrochloric acid, and the process is known as neutralization reaction. This is correct. So our possible answer is D. We continue. Question number 5. Which reaction will result in the decrease in pH? My dear learners, we only decrease the pH of the substance by adding an acidic substance to the substance. Now, that is only possible if we are going to be increasing the acidity, and we increase the acidity by decreasing the pH. Because we understand in chemistry that the lower the pH, the higher the concentration of an acid. Now, what is possible out of the impossible from the options given? We have A, by adding calcium hydroxide to acid soil. We understand that calcium hydroxide neutralizes acidic soil. So meaning we expect, as we are neutralizing an acid, the pH to be increasing. So this A is not the correct answer. Adding citric acid to sodium hydrogen carbonate solution. In nature, we understand that sodium hydrogen carbonate is an acidic salt. And what we are adding is also acidic. Meaning, as we are adding citric acid, which is an acid, to a substance which is already an acidic, we expect the pH of the substance to decrease, because we are going to be increasing the concentration of the acidic substance. So B is likely to be the answer. C, adding sodium chloride to silver nitrate. This is not possible. Adding sodium hydroxide to hydrochloric acid. This is neutralization. It is not possible. So the only possible answer is B. Question number 6. The oxide of element X was added to an acid. It reacted to form a salt and water. As we can observe from what we have in the beaker, what is the pH of the acid before the reaction, and what type of element is X? Okay, my dear learners, we need to understand that initially this substance has been labeled to be an acid, and every acid should have the pH less than 7. So from our options, we can check and use elimination method to eliminate those options which are completely what? Wrong. A, greater than 7. This is completely what? Wrong. Greater than 7, wrong. Less than 7, less than 7. So we have the answer between C and D. Now we need to come to the type of element X. Now, we understand that an acid will only react with a basic oxide to form a salt. If we react it with an oxide made from a non-metal, we are not going to neutralize an acid. When we go back and look at the question is saying we are forming a salt and water. So meaning this should be an oxide of metal. So from our options, the qualifying answer is C. Question number 7. An aqueous solution of the organic compound methylhamine has a pH greater than 7. So our target is greater than 7. Which statement about methylhamine is correct? Now, we understand that since this methylhamine is having the pH greater than 7, this substance is likely to be a basic substance, because only the alkaline or basic substances have the pH greater than 7. A. It neutralizes an aqueous solution of sodium hydroxide. This is wrong because a basic substance cannot react with another basic substance, because sodium hydroxide is also a base. B. It reacts with copper carbonate to give carbon dioxide. A basic substance to react in such a manner, in such a way that it reacts with copper carbonate to produce carbon dioxide. This is impossible. It reacts with hydrochloric acid to form a salt. This is likely to be the answer, but we need to wait. D. It turns blue litmus red. Okay. D is completely what? Wrong. A basic oxide is able to turn a red litmus paper to blue, not what has been presented on the option D. So here the answer is C. Why C? Because since this substance is basic and this substance is acidic, these two substances are that ability to react together to form a salt. That's a very correct answer. Question 8. Which type of reaction always forms a salt and water? We have discussed this a lot. This is a neutralization reaction. And the reaction is as a result of the possible chemical reaction between an acid and a base. Question number 9. An alloy contains copper and zinc. Now, looking at zinc and copper, these two substances are able to form an alloy known as brass. Some of the zinc has become oxidized to zinc oxide. From this mixture of copper and zinc, we are having this zinc reacting with oxygen to form zinc 2 oxide. Pardon me, no 2 there. Zinc 2 oxide. Okay? We are analyzing the question. What is the result of adding an excess of dilute sulfuric acid to the alloy? Now, allow me to explain this. We understand that this alloy is having copper and zinc. Now, in the process, this zinc was oxidized to form zinc 2 oxide. This substance was reacted with sulfuric acid. What are you going to observe at the end of the reaction? We understand, my dear learners, that this copper is not reactive. Copper cannot displace hydrogen ions from this acid, sulfuric acid, because hydrogen is more reactive than copper. In this case, copper is not going to react. What is going to react now is zinc 2 oxide plus sulfuric acid to form zinc 2 sulfate plus water. Remember, we are not going to extract copper from this substance, as we'll be reacting this substance with the sulfuric acid. The copper is also going to be there. So we are going to say copper is going to remain unreacted. So this is in aqueous state, this is colorless. This substance has a pink brown color. So we are likely to observe a colorless solution which is going to have the pink substance settled at the bottom of a container in which the reaction is taking place. So we can go back to the question and see what is there on the options. So A blue solution and a white solid remains. According to my explanation, I said the colorless. B, a colorless solution and a pink brown solid remains. This is likely to be the answer. The alloy dissolves. It can't dissolve because copper is not able to react. The alloy dissolves. It can't dissolve. Copper is not able to react. Even if it is going to dissolve, copper is going to remain as an insoluble substance. So these are wrong answers, my dear learners. Interesting. We continue. Which is not a typical property of an acid? So we are looking for the answer which is not a property of acids. Number one, A, they react with alkalis producing water. This is true. They react with all metals producing hydrogen. I was just from explaining the behavior of copper with an acid. I was saying copper is not able to displace hydrogen ion from a sulfate. So it is not true for us to say all metals. Even copper is a metal, but copper is not able to react with acids. Therefore, B is likely to be incorrect. C, they react with carbonates producing carbon dioxide. This is true. They turn litmus paper red. This is a property of every acid. So the answer, which is not a typical property of an acid, is B. Not all metals react with acids. That's the reason why when we are giving the properties of acids, we say reactive. Should I say the properties of metals? We say reactive metals react with acids to form salt and hydrogen. We don't just say metals. No, we say reactive metals because we understand not all metals react with acids. Very good. Moving forward. Which of these pairs of aqueous ions both react with dilute sulfuric acid to give a visible result? I am going to read this question again. Which of these pairs of aqueous ions both react with dilute sulfuric acid to give visible results? Meaning, when the reaction is taking place, we should be able to see some changes, something we can see. We understand that not all reactions are able to react and form the products that can be seen by their characteristics. For example, you cannot tell me that when you react sodium hydroxide plus hydrochloric acid, by observation we are going to see that sodium hydroxide and water have been formed. We can only observe that there's the change when we add an indicator, but when a chemical reaction is taking place, we are not going to see that there's a visible result. In this case, we need an indicator to be added so that we see that a new substance has been formed. But in this question, we are being questioned to identify the ions which, when they react with dilute sulfuric acid, should be able to produce visible results. Those results should be visible by the time the products are going to be produced. Now let us answer the question. How do we see that a chemical reaction is taking place without using an indicator? We can only witness that if out of the chemical reaction a precipitate is able to be formed. Number two, if out of the chemical reaction bubbles are given out. Bubbles indicates the production of a gaseous substance. So out of those products, we are going to answer this question. We are having A, barium ion and chloride ion. So we have sulfuric acid. We put barium there. We understand that when we are looking at Baleka sulfates, we say all sulfates are soluble except Baleka sulfates, which are barium sulfate, lead sulfate, and calcium sulfate. So in this case, we are going to have this barium sulfate, which is an insoluble salt, being formed. So we are going to observe white PPT. This will be observed, this will be visible. A chloride is not possible, this is not the answer. We cannot react a chloride with sulfuric acid to form a visible result. It's not possible. We come to B. Barium we have witnessed. Carbonate. When we react a carbonate with sulfuric acid, we are likely to observe a visible result. Definitely, when we are having a carbonate, plus sulfuric acid, the hydrogen ions from an acid will attract one oxygen atom from a carbonate. Now, when we extract one oxygen atom from a carbonate, we are going to remain with carbon dioxide. This carbon dioxide is the one which is going to be given out in form of bubbles. Therefore, we are going to see that there is a carbonate in solution. So this is likely to be the answer. Ammonium, we cannot form a substance which is going to be visible from ammonium and the chloride. From a carbonate, yes, but ammonium, no. So the answer is B. We go to question 12. Barium hydroxide is an alkali. It reacts with hydrochloric acid. How does the pH of hydrochloric acid change as excess of aqueous barium hydroxide is added? Now, my dear learners, here you should understand and be able to analyze a question that this acid is our target. How does the pH of the acid? So we are going to center our mindset on the changes that are going to take place on the pH of hydrochloric acid. We understand that barium hydroxide is a base, and this substance is acid. Now, we expect when a base and an acid are reacting, the pH of the solution to be increasing. Why? Because we are forming a substance which is likely to be neutral. What is going to be formed is a salt known as barium chloride. And that barium chloride should have the pH of 7 when the reaction is over. So we are having A. The pH decreases from 14 and becomes constant at 7. Decreases, we are against that. we expect the pH to be increasing. So even B is wrong. So these two answers are wrong. The pH increases from 1. We understand the pH of hydrochloric acid is 1 because it is a strong what? It's a strong acid. So we are saying the pH increases from 1 and becomes constant at 7. This is an excellent answer. The pH increases from 1 to above, no, not above 14, because, or should I say to about 14? This is not the answer, reason being that when that happens, we are going to have an alkaline instead of having a salt being formed. Question 14. Should I say question 13? The diagram shows two substances, X and Y, being heated together. We are having universal indicator paper. The universal indicator paper turns blue during the experiment. Now, our target is this color change. Here they are telling us that after the reaction there was a color change on the color of our indicator. We are being told that the color changed from its original color to blue. And the substance mainly which is able to change the color to blue should be a basic substance. Now, we understand from this setup on the test tube that this substance which is going to change the color on the indicator here should be in a gaseous substance, because a solid substance cannot move from this level to that level where we are having just a gas, because here we are supposed to have a gas, and this gas should be able to react with this indicator, causing it to change the color. And the only gas which has that ability is ammonia. Ammonia is the only existing basic gaseous substance which is able to turn a red litmus paper to blue. Now, what are substances X and Y? We need to move together, my dear learners. I'm going to work out something. Let us look at A. We are having ammonium nitrate. I'll present the chemical formula of ammonium nitrate here. I told you that I'll be taking time to answer questions because I am preparing you for exam and not just to know the answers of this paper, because next time you are going to meet similar questions, but you should be able to analyze them the way I am doing it today. So we are having ammonium nitrate and HCl, which is hydrochloric acid. Looking at what we have. So from this reaction, you just need to forgive me, I paused the video, I was caught somewhere. So from the reaction, what we are going to have here, we understand that ammonia is the only existing radical with a positive charge, so we have a positive there, which will react with a negative halogen, which is chlorine there, to form sodium, should I say ammonium chloride, plus nitric acid. Now, this nitric acid will be in aqueous state. Even if we can have some vapors moving upward, we are not going to have the blue color there change on the paper indicator. It's not possible. So A is not a correct answer. We come to ammonium nitrate. Ammonium nitrate and sodium hydroxide. So we are going to say ammonium nitrate once again plus sodium hydroxide. What is going to happen here? So we have sodium, we also have hydroxide. Then we have ammonium, we also have a nitrate. These substances are reacting. This is negatively charged, this is also negatively charged, this is positive, this is also positive. So we expect this substance, sodium and the nitrate, to react to form sodium nitrate. Now, this ammonium is not stable. Instead of ammonium reacting with hydroxide, ammonium is going to donate one hydrogen ion to hydroxide to form water. Now, when we remove one hydrogen atom from ammonium, we are going to remain with ammonia. This ammonia is basic in nature. We understand that since ammonia is a base, it will be able to change a red litmus paper to blue. So this is likely to be the correct answer. Sodium carbonate and an acid will give us carbon dioxide. Sodium carbonate again with sodium hydroxide is not making sense. So the answer is B. Go to a different question. A gas is escaping from a pipe in a chemical plant. A chemist tests this gas and finds that it is an alkaline. What is this gas? We are not going to waste time here. We are from talking about ammonia. Ammonia is alkaline. Why? Because when we react ammonia with water, we form ammonium hydroxide, and this ammonium is an alkaline solution. Ammonium hydroxide is an alkaline solution. Therefore, ammonia is also alkaline because it dissolves in water to give us ammonium hydroxide, which is an alkaline solution. Interesting, my dear learners. I'm trying to teach instead of just answering questions. We go to 15. The graph shows how the pH changes as an acid is added to an alkali. Now, my dear learners, here you need to realize that every time we are having an acid and an alkali reacting, a salt and water are formed. Now, the question will be, since this salt is going to be formed, what type of a reaction will be this? When an acid is reacting with an alkali, the reaction is known as neutralization reaction. And if the reaction is neutralization, it means the substance with a pH of 7 should be formed, because the characteristic of that substance which is going to be formed should be neutral. And the neutral substance have the pH of 7. So the only substance here which is near this pH 7 is C. Question number 16. Dilute hydrochloric acid is added to a solid S. A flammable gas G is formed. Gas G is less denser than air. So we are giving the properties of this gas G. So we are saying this gas is flammable. This gas is less denser than air. What are substances S and G? Now, we are going to start with the part where we are having gaseous substances. Out of the part where we are having gaseous substances, we just have hydrogen and carbon dioxide. Now, the properties of hydrogen, you understand that hydrogen is able to react with oxygen to form water, And at the point where hydrogen will react with water, there must be combustion. That's the reason why we say the identity test for hydrogen is that it reacts or it burns with a pop sound. So the only gas which is able to burn with a pop sound to form water is hydrogen. So this flammable gas should be hydrogen. We are going to say B and D are wrong answers. Again, we are going to reason by saying, okay, what we have here is dilute hydrochloric acid. Between copper and zinc, which element is able to react with hydrochloric acid to form hydrogen gas? The answer is where we are having zinc and hydrogen. Copper is less reactive than hydrogen, therefore copper cannot displace hydrogen from its acid. Moving forward. An aqueous solution of copper 2 sulfate was made by adding excess copper oxide to dilute sulfuric acid. The mixture was heated, stirred, and then filtered. So we are having this mixture, dilute sulfuric acid, copper 2 oxide heated together with sulfuric acid. After filtration, we are having this substance, which is copper 2 sulfate. What is the question? What was the pH of the acid before adding copper 2 oxide and of the solution after filtration? So what is the pH? What is the pH of copper 2 sulfate? This copper 2 sulfate is a neutral salt, so it has the pH value of 7. Before copper 2 oxide was added to dilute sulfuric acid, the pH was less than 7 because it is acidic, and it has about the pH of 2. Therefore, the pH should be less than 7. So greater than 7 out, greater than 7 out, less than 7. The pH of the filtrate here, copper 2 sulfate, is 7. This is the answer. Less than 7, greater than 7, no. Okay. We continue. We go to question number 18. Which are properties of an acid react with ammonium sulfate to form ammonia? This is not possible. Acid, just give us an example. I give you an example, sorry. I get ammonium sulfate, and then I react it with an acid. What is going to be formed here? Maybe ammonium chloride plus whatever, but this is not making sense. More especially that this substance is acidic, this substance is also acidic. You need to understand that this is used as fertilizer, and fertilizers are acidic in nature. Okay? So to neutralize an acid, we use a base, not another acid. No. Tens, red, litmus, blue. No. We have talked about this. The answer here is G. We go to question number 19. Carbon dioxide is produced when X reacts with ethanol. Y react with sodium carbonate. What are X and Y? So our target here is calcium carbonate. Should I say carbon dioxide? Which reactions are possible? When we look at ethanol, ethanol is flammable, and when it is burning, Since we only have oxygen gas in nature or in the atmosphere that supports burning, it's possible ethanol can react with oxygen to form water and carbon dioxide. So X is suspected to be oxygen. So hydrogen, no. We cannot react hydrogen plus hydrochloric acid here. These two are not possible. Now, which substance is going to react with sodium carbonate to form carbon dioxide? I guess it should be HCl, because HCl plus sodium carbonate, you witness that sodium metal will react with a chlorine here to form sodium chloride. When that happens, it means we are going to remain with a carbonate and hydrogen in solution. Now, hydrogen is going to get one oxygen from a carbonate to form water. Now, when we remove one oxygen atom from a carbonate radical, we are going to remain with carbon dioxide. So this reaction is possible. This is not possible. This is possible. The answer is C. We continue. Ant stings. Ant stings hurt because of the methanoic acid produced by the ant. Which substance could most safely be used to neutralize the acid? This is very simple, my dear learners. So we need just to look at what the substance which this ant is going to produce. The substance is acidic. Therefore, we need a base to neutralize that acid. So car battery here is wrong because this is acidic. We cannot put acid to acid. We are going to increase the acidity. Lemon juice will increase the acidity because the pH there is 3, meaning the lemon is acidic. Oven cleaner, this is too strong. It's basic, but it is not safe because this is too strong. It can burn your skin. Baking soda, yes, that is excellent because this pH is favorable and this substance is basic. Very important. So here the answer is A. The diagram shows an experiment. Now, what do we have from the experiment? From the experiment, without even wasting time, we have the reagents, sodium hydroxide, reacting with ammonium chloride. Sodium will react with a chloride to form sodium chloride. And then this hydroxide will get one hydrogen from ammonium. One hydrogen from ammonium will be removed so that it can react with hydroxide to form water. Now, when we subtract one hydrogen ion from ammonium, we will remain with ammonia. What happens to these papers? We are having this gas, which is ammonia. Ammonia is not going to cause this blue litmus paper change because it is already blue. So this will remain blue. And then this substance which is red, the one which is going to change to blue. So blue litmus paper, change. So elimination method. Change color, no. Change color, no. No color change, yes. Change color, yes. The answer here is C. No color change, yes. No color change, no. The red will change to blue. So the answer is C. We go to question number 22. Two indicators, bromophenol blue and Congo red, show the following colors in acidic solutions and in alkaline solutions. So we have that indicator bromophenol. We are having in acid, it is giving us yellow. Alkaline, it is remaining blue. Congo red in acid, it is giving us violet. And then in alkali, it is remaining red. A few drops of each indicator are added to separate samples of a solution of pH 2. We understand the pH 2 is acidic. Yes, that is analysis. Therefore, we are going to say, what are the colors of the indicators in this solution? So, bromophenol blue, Congo red is. So, in acid, we have observed that bromophenol blue is changing yellow, and Congo in acid is changing to violet. So, the answer here is D. We go to question 23. Which statement about the reaction of acid is correct? They react with ammonium salt to form a salt and ammonia only. No, this is not true, because in the reaction, water is also given out, so we can't go for that. They react with metal carbonate to give a salt and carbon dioxide. Acids, one item is missing here. When acids are reacting with metal carbonates, water is also produced. They react with metal hydroxide to give salt and water. This is likely to be correct. They react with metals to give a salt, hydrogen, and water. Wrong. Here the answer is C. D is wrong, because when metals react with acids, what are formed are just salts and hydrogen gas only. Which substance is the most acidic? With a lower pH. The substance with a lower pH will be more acidic. Here the answer is B. Question number 25. The graph shows how the pH of soil in a field changes over time. At which point was the soil neutral? At this point. Why? Because we are having increase in pH. We understand we are increasing the pH upward. So this side we have acid. This side we have alkaline. Now, you observe that the soil needs to be neutral, and B is at the same level with 7, which indicates the neutrality of the soil. So for today, this is where we are going to end, and I just hope you have enjoyed the lesson. Please don't forget to subscribe. Make sure that you do that, so that next time when I post a new video, you are going to be notified that there is a new material you are supposed to watch. I appreciate you for being my followers and my learners. Thank you so much for today. Enjoy the rest of the day. Thank you.